Okay, let's get started. Welcome to Kojo's Pre-Algebra. Today we're going to talk about systems and how we solve those systems. There's different ways to solve systems. There's three right off the top of my head, which is graphing, substitution property, and elimination. But let's talk about what systems are first of all. Systems are two equations or two linear equations for now and how they relate to each other. Is there a point of intersection? There's three different possibilities when you compare two equations to see how they relate to each other. Are you asking, do they have one solution that will make them both true? Do they have anything in common? Or do they have all points in common, so they basically represent the same thing? Or do they have nothing in common and there's nothing that they can share or be intersected at all? So here's the two equations we're going to talk about, and today we're going to focus on two types, mainly graphing, and we're going to have a discussion at the end about substitution. So the first thing you have to do, I put it up here for simplicity's sake because at this point you should be able to take an equation and to put it into slope-intercept form, or to take it from slope-intercept form or any other kind of form and put it in standard form. You'll be getting equations on our test that will be not necessarily in slope-intercept form. You're going to have to manipulate that because that's the easiest way to graph systems, is to first find out how to graph them easily and quickly, and that is to find the slope and the y-intercept. So I have these in slope-intercept form. You have to make sure that the y has a coefficient of +1, and we put it in y equals mx plus b form. It already is in that form, so we're in good shape. So we identify the slope and the y-intercept for each. So I'm going to come over here, and I'm going to say, okay, for this one, my slope is -1, which is -1 over +1, which means it drops down 1 and runs 1 because it's a negative. The negative has to only go with one value, either the rise or the run. It doesn't matter which one you assign it to when you're graphing, just to see the line, to see the slope of the line and see how it lines up, so you don't have to go to the end of the paper if I give you large numbers. Remember, you can also count and make these units different. You can count by ones typically, but you can count by halves, you can count by quarters, you can count by fives, tens, whatever, hundreds, depending on the values that you have to graph. Basically, what sets that stage is the y-intercept. So the y-intercept here is 1, and then we have the slope here is -1 also, and the y-intercept is -3. So it's very important that when you graph these, you label everything. So we start with the first one. The y-intercept is 1. And the slope is -1. So we're going to drop down 1 and over 1. Now, because I can manipulate this a little bit, if I put these side by side, it's kind of difficult, right? It's a little bit of a pain, to make all these things. So I'm going to go -4 over 4, because that also is -1. I can manipulate it to make my life easier. So 1, 2, 3, 4, 1, 2, 3, 4. Okay? So now, see how I can do this. I'm going to connect these. Yeah. All right. And remember, what you have to do, you have to label it. So it's going to be y equals -x plus 1. Now we're going to do the second one. The second one, we go and we say the slope of the y-intercept is -3. 1, 2, 3. And the slope again is -1. So this time I'm going to do a little bit more. I'm going to say, okay, I'm going to just not go with the -1, 1. I'm going to do -3 over 3 because that equals -1. So I'm going to drop 1, 2, 3, and 1, 2, 3. Boy, look at this. Now I'm going to reverse it. I'm going to go up 3, 1, 2, 3, 1, 2, 3. Because it doesn't matter which direction I go, right? As long as that I still stay. I can manipulate that negative around. I can go -3 over 3, or I can go 3 over -3. When I'm working, I can move that negative to the denominator. So now, I look at these two. Okay, you got to realize that this is, and go back to when we were talking about parallel lines. What do they have? The same slope. Well, these have the same slope. Now, my drawing is kind of wicked. So we're going to write y equals negative x minus 3. And I'm recalling all of a sudden, oh, parallel lines have the same slope. Well, these have the same slope, and these are parallel lines. So how does the system relate? Do they have any points in common? Is there any point that they share that will make both equations true, which would be the system? That here's the solution to this system. No, the answer is none. Null set. They have nothing in common. They are parallel lines. And it's a good check because they have -1 each as a slope. And if you remember that, do you have to graph all this? Only if I said prove it, then you have to graph it. All right, the second one, again, this one is in slope-intercept form, but this one is not. So we're going to put this one in slope-intercept form. And now I'm going to identify the slope. Now notice, we already know we have a difference here because this slope is 1 and this slope is -1. Some of you may need to organize your material over to the side in your numbers so you don't get confused. You might want to write m equals 1 and b equals 1. Here, m equals -1 and b equals 7. Remember, already we know that they're not parallel lines because they don't have the same slope. So I'm going to come over here, I'm going to say, okay, my y-intercept is 1 for the first one, and my slope is 1, and I'm going to make it easier. I'm going to go 4 over 4 again. 1, 2, 3, 4, 1, 2, 3, 4. And that was, see, I've got enough of a slope so I can draw it. It's not that the dots aren't right on top of each other. Remember, you have to put the arrows on the end, and we have to label our graph. Now, in the second one, we've got b equals 7. 1, 2, 3, 4, 5, 6, 7. And the slope is -1, right? So we're going to go, I'm going to do that thing again. I'm going to put -3 over 3 because this is getting ready to go off the table if I go up. So instead of going -3 over -3, I'm going to go -3 over 3 so that I have -1. -3 over 3 is -1 slope. 1, 2, 3, 1, 2, 3. Oh my goodness. 1, 2, 3, 1, 2, 3. Well, already you should know that you're going to have a point of what? Yes, a point of intersection. Now, all for our purposes right now, everything is going to have an exact point of intersection. So you don't have to worry about fractions. That's not always true. And when those types of happen, when you know, right now you know you're going to be getting points of intersection that are exact, not fractions. That's not always going to be the case. So graphing is not always the best solution because you can't guesstimate where it intersects. So that's where substitution comes into play or elimination to solve for systems. And we'll touch on substitution in a minute. So this one is y equals -x plus 7. So there is one point, and exactly one point, that will make both of these equations true. So the solution for this system would be what point? 1, 2, 3, 1, 2, 3, 4. The point 3, 4. That's the point of solution. That's the solution for the system. And you do that by graphing and analyzing the graph. Now these two are going to be, you try this. You pause the video and you try this one and see what happens. Welcome back. I hope you got the same line, the exact same line. Because what we have here is we're going to put this into, well, I think that you got the same line, which means that all points are common. Every point is a solution because they are the same line. So this system is, they equal each other. They both, it's all points have in common. Now we have Let's talk a little bit about the substitution property instead. Sometimes when you know that you're going to have fractions and you can tell by looking at it, that, like let's say you get a y-intercept that's 3/2. That's a problem, or 3/4. So we use substitution property. This is a system, and you simply say in this, it tells you that y equals what? 5. So for every y, you put a 5. And we get x plus 4. Okay, x is going to equal what? 1. All right, we know what the 1 point is. We know what the x is. How do we find the y? That's right. We go back, and we can't use this one, but we go back to this one, and wherever there's an x, we plug in a 1. So 1 plus 4 is 5. What a surprise. So what is our point? 1, 5. That's the point. That's a solution that will make them both true. What I want you to think about is if I change this a little bit and I asked you to use these equations instead, right? To use the substitution property for equality. Go back and try to solve this problem using the substitution property for equality. You don't have a number. It's not y equals 5 now. It's y equals negative x minus 3, wherever there's a y. Or you could use this one. You've got the y's isolated. Try that. Bring that in tomorrow and see what you can do. And have a great day. Write down 2 things you learned and 1 question you may still have. And bring this problem work with the substitution property of equality. Remember distributive property. I don't know if it applies here really. Adding like terms. And then how to evaluate that. All right. You guys have a great day. And I will see you in class tomorrow.